So we've talked about inference for one proportion, inference for one mean, and now we're going to talk about inference for a difference in proportions. So we're going to start talking about the distribution, and then we'll move on to the inferential methods. But one of the things that makes this section challenging is that it can sometimes be difficult to determine if you're doing inference about one proportion or two proportions. So sometimes we're doing inference about p, which is our population parameter for a proportion. Try saying that 5 times fast. And we're using our sample statistic, p hat. And other times we're doing inference about two proportions, where we have the parameters are p1 and p2, and we're using the sample statistics p1 hat and p2 hat. And the question is, how do we know which situation we're in? And the way to solve this is to think about the data. So if there's just one categorical variable that we're thinking about, then it's inference for one proportion. If there are two categorical variables, then we're doing inference for two proportions. So I have some data from the General Social Survey. It's a nationally representative survey of Americans. We're going to think about some questions that we could ask of this data. So we might ask, what are some reasonable values for the proportion of people who are self-employed? We might be able to find the proportion of people who are self-employed, p hat self-employed, but we might want to find a confidence interval around that. And so this is inference for a single proportion. So if we thought about this, we would need to compute something out of the total number of people, and we'd need the number who are self-employed. And so then the data is going to look like just one categorical variable. I actually have a little bit of the data here. This is the first 10 rows. It goes on and on. There's several hundred cases here, but you could have a variable like self-employed or works for somebody else, and then that categorical variable just has two categories. Either they work for someone else or they're self-employed. So we would figure out how many rows there were in the whole data set. That would be the bottom of our fraction, and then we'd put the number of people who are self-employed. So I just have one on this screen, but there'd be more in the data. And that would be our sample proportion. So this would be inference for one proportion. And now here's another example where we could ask, is the proportion of people who are self-employed different between the people who work for the government and people who are private employees? So I could think of this in terms of notation. I could think of it as like p hat government and p hat private employees. And the notation gets a little bit weird here because both of these are going to be the p hat, the proportion of people who are self-employed, but between whether they work for the government or whether they're private employees. So if I thought about the data, I could maybe see that there's two categorical variables here, whether or not someone is self-employed and whether they work for the government or they're a private employee. So here's what that data looks like. Again, I've just given you the first 10 rows and it goes on, but I either have someone works for someone else or they're self-employed, or they work for a private company or they work for the government. So there's two categorical variables there. And we'll go through some more examples of this in synchronous class so that we can practice. Let's say that you have figured out that you're in a situation where you need to do inference for two proportions. We're going to need a standard error formula. And the standard error for the p1 hat minus p2 hat is this equation, the square root of p1 times 1 minus p1 over n1, where n1 is the sample size of the first group, plus p2, 1 minus p2 over n2, and n2 is the sample size of the second group. And we're going to need to check a bunch of conditions. It's basically the same conditions that we checked for inference for one proportion, but we just have a lot more things going on. So I need to check n1 times p1 greater than or equal to 10, n1 times 1 minus p1 greater than or equal to 10, and the same thing with n2. n2 p2 and n2 1 minus p2. All of those things need to be greater than or equal to 10. And then the issue, which I think we had with one proportion as well, is we don't know p1 and p2, so what do we do? And that'll be in the next section.